Hi guys, this video is all about factoring. These are mostly polynomials that have higher exponents than an x squared. So they're mostly x cubed, x to the fourth, x to the fifth, and higher. I threw in a couple of x squared ones just for review, but I do have a separate video that explains the x squared kind, which those, remember, are called quadratics, and so I have a whole separate video that explains how to factor just those types. So these will be a little bit harder. You can tell what type to start with by the number of terms, so that's how I have split up my examples in this video. So this first page of examples, we are doing things that have two terms in them. Like if you look at number 1, that means there's a 16x squared and there's a 64, so those are two terms. These kind will also have perfect squares. Perfect squares. Now let's just do a little reminder to the side here. A perfect square is any number or variable that you can take the square root of evenly. Like, let's say I had 81, let's just say 81. The square root of 81 equals 9. So 81 is a perfect square. Let's say I write down x to the 10th power. If I try to take the square root of x to the 10th, I would get x to the 5th. So x to the 10th is a perfect square. And I could have both a number and a variable, like let's say 25y squared. The square root of that is exactly 5y. So those are all examples of perfect squares. So we'll just leave that jotted down over here to the side. So in our and also these kinds that we're going to do have to have a minus sign in them. If they have a plus sign, you cannot factor them. Alrighty, so two terms. Now, did you notice I wrote GCF first all over the place here? I wrote it here, and I wrote it there, and I wrote it on every single page after this too. You have to take out the greatest common factor first, no matter what kind of factoring you're about to do. So, 16x squared minus 64, both of those can be divided by 16, so I'm going to factor out a 16, which leaves x squared minus 4, because when you factor out a GCF, all you're doing is dividing it out. All right, now I still have two terms. I have an x squared and I have a 4 in here, and they are perfect squares. I can take their square roots. Let's just write the work for that down. You do not have to write this part down to the side, but the square root of x squared is x, and the square root of 4 is 2. So those are both perfect squares. So the way that I factor this is I'm going to have two parentheses, two pairs of parentheses, and I put the square roots in there. So I do x minus 2, and in the other one I do x plus 2. So in your factoring you get 1 minus and 1 plus. All right, let's look at number 2. 49 minus 9x to the 4th does not have a GCF, so we don't have to worry about that. But that problem does have two terms, so we know we're on the right track. If we check that they're perfect squares, let's see, can I do the square root of 49? Yep, 8 equals 7. Can I do the square root of 9x to the 4th? Sure, it's 3x squared. So perfect. They are perfect squares. And now it does have a minus sign. We can see that. So the factoring, you get two pairs of parentheses. You put the square roots in there in order with a minus. So 7 minus 3x squared in the first one, and 7 plus 3x squared in the second one. And that's our answer. Now, as we go along, we should also be checking our answers to see if they can factor again, which is what's going to happen in number 3 here. But in number 1 and 2, those were finished. We were done with those. Now number 3, there is a GCF. Both terms can be divided evenly by 5. So I divide a 5 out of both, which leaves me with 16 y to the 4th minus 1, I don't have to write, w to the 4th. All right. Now, checking. In the parentheses, we have two terms. They're separated by a minus sign. And if we double check for perfect squares, which a lot of you can just do in your head, but the square root of 16y to the 4th is 4y squared, so that's good to go. And the square root of w to the 4th is w squared, so that's good. Alrighty, so I'm going to try to leave space because there's going to be one more level here. But the square roots are 4y squared, and put them in the same order that they were in the original problem. Then minus w squared, and then same thing, 4y squared, but plus w squared. Okay, now I'm about to circle my answer, but I'm not done. So I have 4y squared minus w squared. That's two terms again, separated by a minus sign, and if I write down if they're perfect squares, they are. The square root of 4y squared is 2y, and the square root of w squared is w. So I can factor that parenthesis again. Now in this other parenthesis, I'll temporarily highlight it. This one cannot factor again because it has a plus sign in it, and that is a no-no. We can't factor that. So now we are going to get our final answer. Keep bringing the 5 down. That's important. The GCF keeps coming down in every step. Okay, so the part that's in yellow is going to become 2y minus w, and then 2y plus w, and then we just bring down the 4y squared plus w squared, since it didn't factor again. And that is it. That is our final answer for that one. Now we have page 2, which is two terms still, problems with two terms. But now we would be noticing that they are perfect cubes. And we'll talk about that. And these problems can have either a plus or a minus sign. You're not limited to just the minus sign. So let's talk about the perfect cubes. Let's remind ourselves. Perfect cubes are just numbers or variables that you can take the cube root of. So like let's say I had the number 8. Well, if I try to take the cube root of 8, it does equal perfectly 2, so that is a perfect cube. Let's say if I'm trying to take the cube root of y to the 12th. Well, that's a perfect cube because the cube root of y to the 12th is y to the 4th. And that is because y to the 4th times y to the 4th times y to the 4th multiplies back again to equal y to the 12th. You can just divide the power by the root that you're trying to take. 12 divided by 3 does equal 4. We won't really have any that are that high of a power, but just so you know how to do that. And then let's just test out if 27 x to the 3rd, if we try to take the cube root of that to see if it's a perfect cube, it is, because the cube root of 27 is 3, and the cube root of x to the 3rd is x. So that's a perfect cube. So that's what perfect cubes look like. Alright, so now in our very first problem, you wouldn't know ahead of time that it's this kind, but if you're checking, it has two terms. They are perfect cubes, and there's a plus sign in between them. So we can go ahead and factor this. Now this is a special pattern. You have the first parenthesis and then the second. We put the cube roots, so let's just write it to the side. The cube root of x cubed is x, and the cube root of 8, we did that before, that's 2. So we put the cube roots in our first parentheses. So we have x plus 2. All right, now here's where it gets a little tricky. We square the first term. I'll write all this down in a sec. So x squared, we need that one. Now we multiply together the 2 and the x for the middle, and then we square the 2 for the end. So what we did there was you square, let's first of all call this the first term, and this I'm calling the second term. Okay, so you square the first, and at the end you square the second term. That's how I got x squared and 4. And in the middle, you multiply the first and second. Okay, and then I'm going to write this down for you too. The plus and minuses that you put in the answer, I did a plus already, and then this is going to be a minus, and this is going to be a plus. Now the reason why, there's an easy acronym to help you remember this. The first sign is always the same as the original. The next sign is always opposite, so same, opposite, and the last sign is always positive. A-P for always positive, and that spells out SOAP, S-O-A-P. SOAP, that's just like a little trick to help you remember where to put the plus and minuses. So the plus is the same sign as the original problem. The minus is the opposite sign, O for opposite, as the original problem. And then this last plus is always going to be positive in every single problem that you do. All right, so let's just do a couple more examples that will help. First of all, in number 2, I can factor out a GCF of 5x squared. So I don't even look at what other kind it is until I do the GCF. So if I divide that out, I'm left with x cubed plus 1,000, and that's it, because the x squared divided out. Alrighty, so now I'm double checking the inside of the parenthesis has 2 terms. So far so good. If I attempt to take the cube root of each of those, it will work. So cube root of x cubed is x, and the cubed root of 1,000 is 10. So check, they're both perfect cubes, and there's a plus sign. So here we go. The 5x squared keeps coming. It doesn't disappear. So we're going to factor. So I put the cube roots into the first parenthesis. X plus 10. Plus, because that's the same sign as the original. Now, I square the first, so that's going to be x squared. I multiply the first and second, so that's 10x. And I square the second term, which is 100. And then I can finish out the word SOAP, which means this will be a minus, and that's always positive, so that's a plus. And you're done. All right, and let's try it. I included a minus problem. First of all, in number 3, 2 is a GCF. So divide 2 out of both terms, leaving you with y to the third minus 27. 54 divided by 2 is 27. So now I'm checking to see if it's this kind of factoring. We have 2 terms on the inside. They're separated by a minus. If we see if they're perfect cubes, the cube root of y cubed is y, so that's great. The cube root of 27 is 3, so that's perfect. So the 2 keeps coming along, and we're going to factor this part out. So we put the cube roots in here, y, and then a minus sign because it's the same sign as the original. Y minus 3. Okay, now square the first term, y squared. Multiply the first and second, 3y. Square the second term, which is 3 squared, so that's a 9. And then fill in the other signs. That has to be opposite, so it's plus and always positive, is plus. When you're multiplying the first and second terms to get this 3y right here, you ignore this minus. You just multiply the 3 and the y to get 3y. You're not multiplying negative 3 and y together. All right, so the last thing, I'm going to circle this, the last thing also is that this part of a perfect cube, that part, all those parts in green, they will never factor any farther than that. They are quadratics, but they are not factorable, so don't even waste your time trying. That's always the case in perfect cubes. All right. Now we have polynomials with 3 terms. So if you see one of those pop up, they are going to factor just like quadratics that you should have done in a different chapter. So let's look at our first problem. There's no GCF, and I notice that it is quadratic. So just to review quadratics, we would need to multiply to 12 and have 2 numbers that add up to 7. So the 2 numbers that do that are 3 and 4. So then we factor this. This should just be review for you guys. And it becomes x plus 3 and x plus 4. Now the reason I wrote that example down is to show you how number 1b works. 1b almost looks the same, but it has x to the 4th power and x to the 2nd power, and I did not mean to write an x right there. Okay, so that's what it should have been. X to the 4th plus 7x squared plus 12. The reason this will work exactly the same as a quadratic is because the first power is double the second power. And there's a constant at the end. That is what you are looking for to decide if it would work like a quadratic or not. So since we have that, we have the first power is double the second power, and the last number, the 12, is a constant. It works exactly the same where it needs to multiply to 12 and add up to 7, which we already knew were 3 and 4. So here's how it factors. Since it was x to the 4th, you put x squared plus 3. And same here, x squared plus 4. All right, so the first exponent just gets split up evenly into the first spot of the parentheses. For most of your problems, it will probably be x to the 4th, so it'll just get split up into x squared and x squared. Now number 2 is still a type of quadratic. It works like a quadratic. It is a little harder because there's the 2 in front. So this is, well, number 1, let's check our powers. The 4th power is double the 2nd power, which is 2. And then at the end of the problem, we have a constant. So we know we're okay to use this technique. So it's going to be like a quadratic. So we know we have to find 2 numbers that multiply to 18, because remember, when there's a leading coefficient, you have to do 2 times 9, which is 18. So we need our numbers to multiply to 18 and at the same time add up to 9. 6 and 3 will work. So what we're going to do, I'm going to get rid of some of those lines, is we are going to split the middle term. So that's going to become, we just recopy 2x to the 4th, but the middle is going to be the 6 and 3 now. So 6x squared plus 3x squared, and then plus the 9 at the end. And then what you do so this is splitting the middle term. The 9x squared just got split into 6x squared plus 3x squared. Then we group the first 2 terms and the second 2 terms together and take a GCF out of each. I'll just write a note there. Take GCF out of each. So out of the first parenthesis, we could take out a 2x squared, which would leave you with x squared plus 3. Out of the second parenthesis, we can take a 3 out, which also leaves you with x squared plus 3. And now they both have an x squared plus 3, so we regroup it here to be 2x squared plus 3. So this and that go together. And then the x squared plus 3 that was with both of them is the other factor. And so that is that. So it's just like factoring a quadratic, but it had a higher power, x to the fourth. But all the other steps are the same. So if you need to review that, you could look at my earlier video that was for factoring quadratics. And then the final kind here is anytime you come across a polynomial that has 4 terms, what we're going to do then is grouping. And I just was doing grouping in part of that last problem. So this will be a little bit easier, nothing too brand new. So we have 4 terms, so I'm going to put parenthesis here, and then what I do is just go like that so that the negative doesn't get split apart from the 3. Now take out GCF from each. So in the first parenthesis, in this one, you can divide out a 7x to the second. And when you do that, you're left with x minus 2. And then out of our next parenthesis right there, negative 3x plus 6, let's take out a negative 3. It's always good to take out the negative if it's the first thing. And that leaves you with x minus 2. And then that's not a coincidence that these came out the same. So then what we do is we rewrite 7x squared minus 3 times x minus 2. So this came from 7x squared minus 3 goes together in that parenthesis. And then you just write x minus 2 once. So that is our final answer for number 1. And now you should always still be looking for a GCF. So in number 2, if I scan across, I see that I could divide everything by 2. So first and foremost, take a 2 out of every single thing. So 5x cubed plus 6x squared minus 20x minus 24. Okay, now we have, in this parenthesis, we have 4 terms. So it's this kind where we're going to attempt grouping. So we group these first 2 together and these second 2 together. So keep that 2 written on the outside. Now I'm taking a GCF out of each. Okay, so the first thing is I'm going to take a GCF out of that part. And the GCF of that would be x squared. I'm putting a big parenthesis there to separate the 2. So x squared factored out would leave you with 5x plus 6. Then in the next parenthesis right here, we can evenly divide out negative 4, which leaves you with positive 5x plus 6. Okay, so we're doing good because 5x plus 6 and 5x plus 6 are the same. So, like before, we take this x squared and this minus 4 and we put them together. X squared minus 4. We put the 5x plus 6 right next to that. The 2 is still in front. We don't need extra pairs of parentheses. And then, this is a good example because if you're about to circle your answer, don't do that because look at right here. X squared minus 4 is the very first kind of problem we did on the first page. It's perfect squares, so it can be factored into x minus 2, x plus 2. We still have the GCF 2 in front, and we still have the 5x plus 6 at the end. And that would be your final answer.